All right, so in this we do problem, we have aluminum that is melting and freezing at a temperature of 933 Kelvin. We want to figure out how much energy is required to freeze 2.50 moles of aluminum at that temperature. Now, we're given two bits of information, the enthalpy of fusion for aluminum and the enthalpy for vaporization for aluminum. Now, we're talking about melting and freezing here, which means we want the enthalpy of fusion for aluminum, which means we can ignore that value over there and we don't have to worry about it. We're probably also going to need this 2.5 moles of aluminum as well. So we want to calculate energy that's required. So again, we're using Q for this one, but instead of using Q equals MC delta T, we're using Q equals the enthalpy of fusion times the number of moles. Because what we really want is we want Q, which is kilojoules. So we honestly just look at these units and say, I need to get rid of moles. So for this one, it ends up being pretty easy. We're just going to kind of plug and chug here. The biggest thing, though, with the delta H of fusion is we have melting and freezing. One is endothermic and one is exothermic. So the freezing, which is what we're talking about here, that's definitely exothermic. And so we're talking about an exothermic process here, which means we want a negative 10.9 kilojoules per mole for the enthalpy of fusion for an exothermic process, so negative sign, and we're going to multiply that by 2.50 moles of aluminum that we have. That gives us a total for our energy required to freeze 2.5 moles of aluminum as negative 27.3 moles cancels, and we're left with just kilojoules.